Hello everyone, my name is John Luce,
And I'm Samson Coe.
and today we will be discussing genetic genealogy's wide array of usage as a powerful technology to learn more about ourselves, our ancestors, and where we came from. Based on genealogy, I know that my father's side of the family came to the U.S. from Ireland back in the potato famine of the early 1800s, moved out west to California, and has been there since. And on my mom's side, my grandmother immigrated from Britain to New York, and my great-great-grandparents came to the U.S. from Italy and Czechoslovakia.
As for my family, both my parents are from South Korea, and I was born in India, but I'm a first-generation immigrant to the United States.
Did you know that all humans share 99.9% of the same DNA and only differ with each other in approximately 0.1% of their genetic makeup? Genetic genealogy is a technology that determines how DNA differs between individuals to determine physical traits, and even a person's identity through a combination of genetic analysis and traditional genealogy methods. Extensive research on the Human Genome Project from 1990 to 2003 has led to this discovery, along with advances in microarray technology, a process that determines small differences in genetics from person to person. In 1975, researchers from Stanford University began identifying the fundamental technologies for DNA microarrays. This process involved identifying target DNA strands through fluorescence, which paved the path for future research in this area. Each DNA strand differs from one another, and these differences make up who we are as individuals. Based on these principles, the first modern microarray capable of analyzing thousands of sequences at one time was created in 1995. This was created by Patrick O. Brown at Stanford University. Fun fact, he was also the same founder of Impossible Foods, and the array used glass slides with small sequences of DNA printed on them, with the intent of enabling a new method for relating sequences in genes with complex traits in people. While previous analysis only allowed for gene expression to be seen one gene at a time, this allowed for many genes to be analyzed at once, allowing for us to create a profile of our genetic history all in one test. There are many small wells on a microarray, each with different DNA, and if a trait is identified, the well will light up or fluoresce. This information on which wells are fluorescent is then uploaded into a computer program and analyzed for different traits depending on which genetic testing is ordered. The use of this technology accelerated quickly, with the first private offerings of genetic testing to the public being offered by Family Tree DNA in May of 2000. Soon after, many other companies either formed or rapidly grew, some of the largest and most prominent ones being 23andMe, Illumina, and Ancestry.com. Additionally, companies like Ancestry.com that have been tracing family connections before the emergence of genetic sequencing combined the use of genetic sequencing with traditional methods to create a much broader network of familial connections. One particular group that has been interested in genealogy for over a century is the Church of Jesus Christ of Latter-day Saints, which has been conducting paper-based genealogy through public records, governments, churches, and libraries in hopes of finding past ancestors, and the church has played a major role in funding genetic research at both universities and private sector companies. Another group that has been using genealogy to identify members is the Navajo Nation, which has used genetic testing through blood quantum in order to trace back ancestors to verify tribal membership. There have also been other services arising in recent years that allow people to voluntarily submit their genetic testing results in order to compare DNA with other people worldwide, which has facilitated the process of creating public family trees, but has led to privacy concerns as well. If one person's genetic information is public record, so is information on close relatives. On the other hand, this has also created a large database of public knowledge to be used for research. Two of the most notable services that allow for publication of genetic data are Family Tree DNA and GED Match.
Through all these uses of genetic genealogy, we are starting to understand what makes us human and what really sets us apart. This leads to one of the implications in our society. We are seeing that there is a growing societal shift on race and ethnic identity, when researchers discover that a plurality of ethnic backgrounds exists even in a single individual. They deconstruct existing frameworks in racial identity. And we've seen how race has often been a categorical method to attribute qualities to a subgroup of individuals, evident through the South African apartheid, the internment of Japanese Americans, the Euro-American slave trade, and the societal systems that came with them. Race is far too primitive of a method in distinguishing the complex, subtle differences between human beings. Indeed, a 2017 skin pigmentation study demonstrated that lighter skin color, commonly attributed with Europeans, is a product of the gene variant SLC24A5, which only mutated as recent as 29,000 years ago, with its migrational pattern linked to only a few thousand years. This means that all of the perceived racial differences are an incredibly recent development in the evolution of our species. This research reshapes our traditional normative values in race, and it starts to give us a comprehensive outlook on what truly makes us different. Personalized medicine is yet another implication in the development of this technology. Currently, patients have access to genetic testing using genotyping that seeks to examine their risk for developing a hereditary disease. Companies like 23andMe are also researching a variety of ways that genetic genealogy can be used within healthcare, as their users can voluntarily opt in to allow their genetic data to be used in new drug research. This is the world of pharmacogenetics, a medical specialty that tests gene variations to create personalized treatment. A Northwestern University research concluded as early as 2010 that personalized medicine must become the dominant form of drug therapy in dealing with varying needs of distinct ethnic communities to avoid a, quote, one-drug-fits-all concept. We can also see how the employment of genetic genealogy in law enforcement poses opportunities in forensics with the inclusion of some privacy concerns. This technology can supply a crucial human attribute in police databases, as it has enabled forensic investigators to review high-profile cases that have deficiencies in physical evidence. So, with the advances in the underlying technology that enables the collection of genetic evidence through DNA samples, law enforcement agencies gain a critical tool to analyze accurately an individual's genetic data with even the most minuscule amount of human specimen. Currently, less than 1 milliliter of blood is required to obtain 20,000 nanograms of DNA, of which only 50 nanograms are needed to obtain an individual DNA set, with a margin of error at 0.001%. That's about 1,000 times lighter than a single grain of salt. Furthermore, forensic researchers at Virginia Commonwealth University are studying future methods to use fingerprint impressions to extract enough nanograms of DNA to trace back to its database. This fundamental technology could lead to the prevention of high-profile crimes. One of the most famous recent examples of this is the tracing of DNA through public genealogy databases that led to the capture of the Golden State Killer, who never would have been found without this technology. Through historical analysis of the engineering and systems perspectives, genetic genealogy as a technology offers an array of contemporary and future applications within diverse disciplines of sociology, personalized medicine, and forensic science. This advanced genetics technology requires robust privacy laws regarding individual DNA and requires insight into the motives of major industry players. Though there are many arguments about who can fully access this technology, genetic genealogy nonetheless provides a variety of unique solutions to specific areas such as forensics and healthcare.